So, hello everybody. My name's James Thomas. I'm a developer advocate for IBM working in our cloud division. And I'm here today to talk to you about what I think is a really new and interesting, exciting way to be able to deploy Swift backend, Swift APIs, Swift microservices to the cloud without having to set up or manage any infrastructure to be able to do this. Right now, having to provision VMs or create containers or set up Linux or any of that kind of stuff. And you might think this sounds kind of impossible, right? If I want to run my Swift code in the cloud, surely I have to set up the environments to do this. But I'm going to be showing you a new approach, using something called serverless cloud platforms that allows you to do just that. And in the kind of second half of this talk, I'm going to be doing a live demonstration of using one of these platforms to give you the skills and techniques to go home and do this yourself. Now, at this point, as well as thinking this sounds kind of impossible, right? Serverless, server-side Swift. You might also think that it sounds unnecessary, right? You might think, I like my infrastructure, I like my VMs, I like my containers. Why would you want to take them away from me? Well, the reason is this, right? What's happened? I think when I put the thing in. All right, we're back to old school technology. We're going to use a keyboard. So the reason is this, right? Servers kill your productivity. You might not realize it yet, especially if you're new to back-end development, right? You're mostly doing mobile stuff. But trust me, it's true. And I think by the end of this talk, you're going to agree with me that servers kill productivity. You're going to want to go back to your office on Monday, and if you see any servers kind of hiding, you're going to want to set them on fire and be free forever from what I call the tyranny of looking after infrastructure. So why do I think, right, that servers kill your productivity? Well, imagine you've got a great new idea for a mobile application, right? So you build a mobile app in Swift, and need some back-end APIs or services to go with it. And you've heard about server-side Swift, so you think you can go full-stack Swift. So you build the back-end in Swift, and then you just think you need to deploy it. So you go to your cloud provider's console, you click some buttons, you get some infrastructure, you put your back-end Swift code on there, and you think that's going to be kind of the end of it, right? But what you will suddenly realize, again, if you're new to back-end development, as soon as you provision that first bit of infrastructure, that first VM, that first container, suddenly you've got all of these extra tasks to take care of. If you're using kind of lower-level infrastructure, you have to set up and manage the environment, keep it updated as new versions of the kernel operating system comes out. You need to keep it secure. You know, is your servers, your infrastructure, is it backed up? Is it encrypted? Is it secure? Is it GDPR compliant these days? Very important. And you need to think about, is everything up to date? And hopefully, as your application gets popular, you're going to need to think about scaling, right? Have I got enough servers? Have I got enough infrastructure? Have I got too much, costing me too much money? Do I need to worry about auto-scaling up and down? And after a while, I think you kind of find yourself spending all of your time looking after this infrastructure. I think you can often feel like you get held hostage by your infrastructure. I want to spend time in Xcode writing Swift. You're going to spend increasing amounts of it kind of logged into your cloud provider's console trying to debug some midnight kernel production panic. And this is not really what we want, right? We just want to run our way to run our code in the cloud. I don't really want to have to think about all this kind of low-level infrastructure stuff. So the question is, what can we do about this, right? Maybe you've obviously come to this conference, you're very excited about getting into the world of back-end development. Now I've depressed you and tell you it's going to be this nightmare of looking after VMs and containers. You're never going to get to do any Swift again. Well, fortunately for you, I'm going to talk about, I think, again, a new and exciting way to run Swift in the cloud without worrying about any of that infrastructure stuff. And that is called serverless computing, or using serverless cloud platforms. So let me ask, right, hands up, who's ever heard, before this talk, right, who's ever heard the term serverless before? Wow, that's good, okay, so most of you, 80%, right, can you hands up if you've ever used any of these platforms? Lambda, Azure Functions, Google Cloud, OpenWhisk, all right. Has anyone done anything production? All right, one guy in the back, all right, that's good, right, that's kind of what I expect. So if you've never heard this before, that's okay, I'm gonna kind of go through it. So let's imagine that you're on Twitter, you're on Hacker News, or whatever, and you keep hearing people talk about this term serverless. And rather, as well as thinking that it's a terrible name, you're kind of wondering, what is it? Why is this thing different? Why is everyone talking about it? And if you went to Wikipedia, right, you read the article on Wikipedia about serverless computing, you would read things like this, right? Serverless cloud platforms, serverless applications, they run your code in response to events. right? They manage your compute resources for you. They allow you to build event-driven applications. And at this point, you might, again, stop and kind of scratch your head and think, well, that doesn't sound very different or kind of revolutionary to me, right? What is different about serverless? But serverless is different, and it's different for a couple of reasons. The first is that I think it shrinks the unit, what I call the unit of deployment. So rather than having to push your code into the cloud, having wrapped it in like a Russian doll in terms of like a container and a VM image and onto some infrastructure, serverless cloud platforms allow you to just push your raw code straight into the cloud platform and have it execute on demand when API request comes in. And this is where the term serverless comes from, right? Your code is still going to be running on a server somewhere, but from the developer's point of view, from my point of view, I don't have to worry or think about it anymore at all. All I have to think about is my Swift code. Another difference about serverless is how it handles the scaling. So with serverless cloud platforms, I said your serverless functions, your Swift functions, they get started on demand to process requests as they come in. And what happens is if you get like 1,000 requests in parallel, it's kind of the cloud provider's job to spin up multiple instances of your microservice in parallel to process all of those requests. As long as you followed the architectural guidelines about how to build your serverless functions, the cloud provider will just automatically scale up to cope with, massive amounts of traffic on demand. It's not something you as a developer have to think about, well, how big a container or how big a VM do I need, how much memory and CPU and disk space to cope with requests that's only going to occur in the future, right? Scaling becomes completely the platform's responsibility, which is another thing you don't have to worry about. And with serverless, right, as well as scaling up to cope with loads of traffic, they also scale down. They scale down to 0 because your code gets started on demand to process requests as they occur. And once the request has been processed, it kind of puts the environment to sleep. So if you have idle time in your application, idle time in your backend, when there's no request to process, it means that none of your code is actually running. Now, that's a really, really important factor when we think about the pricing model. So service cloud platforms, like all cloud services today, are pay-as-you-go. You generally get charged for the duration that your functions are running, the milliseconds that they're running to process requests. At the end of the month, your cloud provider adds up all those milliseconds and generally sends you a very small bill. But with serverless, right, you're only going to pay for when you're actually doing work in your backend, when you're processing API requests and users are interacting with your app. So any time that you have idle time, when there's nothing going on, Sunday afternoon, something like that, you don't have to pay for it whatsoever. And this is quite different traditionally how infrastructure has worked in the cloud, where you provision a fixed amount of capacity up front, and it's kind of your responsibility to use it. And for certain workloads, you can go on Google for this kind of stuff. There's loads of blog posts of people talking, hey, I moved my backend to serverless, and I saved 80, 90, 95% of my monthly cloud bill because I don't have to pay for any idle time in my backend whatsoever. So, enough talking about serverless at a very high and kind of abstract level. Let's show me the code, right? Let's show you the code of how to use one of these platforms to actually deploy some Swift and get some serverless Swift stuff working. And if you want to play around if you want to build serverless, what we call serverless applications today, the first thing is you need a provider, right? And today, pretty much whoever your cloud provider is, right, I pretty much guarantee you they have some kind of serverless offering for you to be able to play with. To give you a bit of history about where serverless came from, about 4 years ago now, September 2014, about 4 years ago, Amazon launched a new service to the cloud called Lambda, which was in beta at their big conference, and kicked off essentially this whole serverless movement. They kind of started the whole thing, and they put it out there, and it got very popular with developers. And then start of 2016, most of the big cloud providers said, hey, this is like a good thing. We're also going to launch kind of competing solutions. And today, everyone has one of these things. So there's AWS Lambda on Amazon. Microsoft has Azure Functions. There's Google Cloud Functions. We have one that's now called IBM Cloud Functions. You can see they have a very original naming scheme. But whoever your cloud provider is, they have some kind of serverless offering for you to be able to play with. And it's definitely a misconception, I think, sometimes. People think service is still just an AWS thing, and it's definitely not true anymore. All the big cloud providers are really heavily into it. And the platform we're going to be looking at today is based on an open source technology called Apache OpenWhisk. So this is actually the kind of core technology that powers IBM's serverless offering. And when we built our platform, we decided to open source it and give it to Apache, where it now lives. And recently, both Red Hat and Adobe have come along and started using it and being part of the community. And it's kind of grown into having a fairly big open source community now. And I'm going to show you how to use this to deploy some serverless Swift stuff. But the techniques I'm kind of showing you today are applicable to any platform. They all kind of work in the same way. But I think there are some good reasons to, if you're thinking about doing serverless Swift, I think there's some good reasons to look at a project or platform that uses OpenWhisk. And the first, obviously, is it's open source, right? It's a full Apache project, so you can go to the GitHub repo and dig through the Scala code if you want to understand how it works under the covers. And the reason that we did this, because I think most serverless platforms today are kind of proprietary, secret source cloud provider technology, is that we know that all developers building in the cloud are very worried about vendor lock-in, right? You remember things that happened to Parse.com and other kind of services, and they're worried, especially with serverless, about being tied to some proprietary stack. So we think by open sourcing the platform, it gives developers a bit more kind of long-term security to run it locally, to deploy it themselves, or to use a managed service in the public cloud. But I think the best thing for developers in this room, in terms of doing back-end development with Swift, is the runtime support in OpenWhisk. So with serverless platforms generally, right, you don't have to set up or manage the environment which runs your code whatsoever. You have no access to it. It's completely hidden away from you. So you are dependent on the cloud provider, the service provider, to give you kind of runtimes that you want to be able to use and provide that. And if you look across the different service providers, there's some common runtimes, some that are not so common. So I call them the big three, right? Node.js, Java, and Python. They're supported on pretty much every serverless platform out there, right? They've got really good support kind of across the board, especially Node.js, which is generally the most popular language for serverless applications. But then it gets a bit more interesting. So these are some of the languages that OpenWhisk supports, things like PHP and Docker and binaries, and Ruby's about to drop as well. But the most relevant one, right, for everyone in this room is Swift. OpenWhisk has native Swift support, which means you can push up raw, uncompiled Swift functions straight into the platform and have them execute on demand. And it's the only serverless platform today that has native Swift support built in. The reason for this, obviously, is that IBM has been heavily involved in Swift since it was open source sort of 3 or 4 years ago now, doing things like Katora, some of the cross-platform work for foundation libraries. So it made sense for us, since we're heavily invested in language, to add it into the platform we were developing. But whatever runtime you were going to use, right? You're probably going to use Swift, maybe use something else. The question people have is, well, you tell me that I just write some code and I push it into the cloud. Like, how does the platform know what to do, how to kind of execute it when requests come in? And it all kind of works in the same way, whichever runtime you use. Generally, if you've got some code, right? You've got this mycode.swift. Don't worry about, it's just some kind of example code. Like, if you want to push this into OpenWhisk as what we call serverless function, what you have to do is you have to add a particular function handler, kind of an event handler with a particular name, and that is the function that's going to get called by the platform every time an API request comes in. It's going to pass you the event parameters. Your code's going to run, do whatever you want, whatever Swift code you've written, and whatever you return from that function is going to be kind of serialized back out as the API response. And this is how it works on all the languages. In JavaScript and Java, you just need to add a particular function interface, and that's going to be the kind of event handler that gets executed. So for Swift, for the Swift 3 runtime, this is what it looks like. You have a big Swift file, you can have many functions, you can use external packages, all that kind of great stuff. And you just need to have a function called main, which takes a dictionary of type string any and returns a dictionary of type string any. And you can see it's a very lightweight interface, right? It doesn't require you to do much to your code. It's very, very simple when you finish the kind of core business logic to write the little event handler to make it compatible for the platform. When an API request comes in, it's going to call this function with those event parameters. Now, when we initially added Swift support into the platform, it was like back in the days of Swift 2, and then Swift 3 came along, we added support for that. And obviously, recently, we've had Swift 4, and when we were looking to think about how we could integrate Swift 4 into the platform, as well as just providing it as a new runtime, obviously, we wanted to take advantage of codable protocols, which we kind of heard about this morning. So when we launched Swift 4 support about 6 months ago now, one of the changes we made to that function interface is the ability to kind of natively support Codable. So rather than having to have a kind of dictionary passed into your function and do all those kind of optional checks, which are not very nice and a bit error-prone, now you can just define a kind of native type that implements a Codable protocol, and the platform will automatically do that serialization between data event API requests coming in and the native type. And you can go return a Codable as well, which is really, really nice. And this is actually the interface which also matches Katora's kind of route handling. So if you're familiar with Katora, it's very easy to swap between serverless and server-side. And so you can still use the kind of old approach, but I think going forward, this is going to be much more popular. And we also have callbacks as well if you want to do asynchronous processing. So imagine you've written some Swift code, right? You've put one of these functional handlers in there, and you're ready to push it up into the platform. When you do this, OpenWhisk creates what we call an action. So an action is just the name that OpenWhisk uses for serverless function, right? So when you hear me say action, just think serverless function. So let's do this now. Let me take some sample Swift code from my laptop and just deploy it up and show you how quick it is to get working in the cloud. And you won't see me touch a VM or set up a container or any of that kind of stuff. So let me hide my slides and then mirror the screen and have a drink. Okay, and then I can make it a little bit bigger, right? So, as I said, OpenWhisk is completely open source, right? So if this is the GitHub repo, if you're desperate to go and dig under the covers and understand how this kind of thing works, you can do. And there's loads of ways to set it up locally. If you want to play around in testing and development, you don't want to use the cloud, that's fine. You can do it with Docker Compose or Kubernetes or Vagrant. There's just like tons of different ways. And there's one command you can run, you can see down here, and in about 60 seconds, the whole platform's kind of running locally, which is very nice. But I think for most developers who are using serverless, the big benefit is using it on a public cloud, right, where you can just use it. You don't have to think about setting up anything. And so the instance of OpenWhisk I'm going to be using today is called IBM Cloud Functions. This is just basically IBM Cloud. It's just public cloud, and we have a managed instance of OpenWhisk that you can just sign up and use. You get a very generous free tier, which is really nice to play around. You don't need a credit card, all of that kind of wonderful stuff. But it's just OpenWhisk. It's just that open source project as a managed service in the public cloud. And that's the one I'm going to be kind of using today. Now, wherever you're running or accessing OpenWhisk, the thing you need to do is you need to get some code from your laptop, your development environment, into the cloud. And to do this with OpenWhisk, normally what most people do is there's a little CLI you can download and install, which allows you to create serverless functions from your laptop and invoke them and do all the kind of testing and development. So because let me make this bigger. I use OpenWhisk like every day as part of my advocacy work. I already have this installed. So I hope, can you see at the back? Can you see me typing stuff, or do you need to make it a little bit bigger? Is that okay? Looking at the back row? Yeah, okay. I saw a thumbs up, so one of you can see. So let's have a look, right? Let me run you through. I call this the hello world. It's just like super simple hello world. So I have some Swift code here, hello.swift. And you can see that conveniently it implements the interface that OpenWhisk expects, right? So it's a function called main, which takes a dictionary, returns a dictionary, and it's just a little hello world service, it's like a greeting. It's just going to say like hello stranger, or if you give it a name, it's going to say like hello Sally or hello James, depending on your event parameters. So using the command line that I've already installed, I can say whisk action create. I give it a name, call it hello. And I give it the path to the Swift code. So it's going to push the Swift code straight into the cloud. And I can check it's been deployed, right? So if I list my actions, you can see in my workspace, I have a little function called hello, which is detected is using the Swift 3 runtime. That sounds pretty good. And now I can try it out. So I can say whisk action invoke hello. And what should hopefully happen is it should evaluate that Swift code on a server somewhere and then give me back the result serialized to JSON, which just says hello stranger at the bottom. And I can try this again, right? I can call it again and pass in parameters for my name. So it should say hello James. And then I can say like hello Sally. And it just works, right? I could call this serverless function like 1,000 times in parallel, and it would just work. Don't need to worry about load balancing and all that kind of complicated stuff. I just invoke it on demand, and I'm just going to pay for it, which is really nice. Now, obviously, this kind of example, you probably don't, this is not an API hopefully no one wants in their application, right? It's just Hello World API. So let's think about maybe something that's a bit more like realistic. Imagine if you're building a retail app, mobile app for a retailer, right? You can buy stuff through the app. And your client, the retailer, comes to you one day and says, hey, I want to integrate Bitcoin into my application. I want users to be able to pay for stuff with Bitcoin. And you say, okay, that's fine. But you know that Bitcoin as a currency is very volatile. It fluctuates like minute to minute. So you can't just take static prices in Bitcoin and put them in a product database because it's going to be out of date straight away. So you think one way to handle this is to have some kind of API that during that checkout process, you can just do real-time conversion from, euros straight into the equivalent of Bitcoin and, never be out of date. So you know that most of the time this is going to be idle, so you think this is a good use case for serverless. So I have some Swift code, maybe it's a bit more realistic, that I wrote to actually do this. So we'll quickly walk through the 30 or 40 lines of Swift code to show you what it looks like, and then we'll deploy it and get it working in a minute. So you can see this is a little bit more realistic, right? I've got some probably pretty terrible Swift code, but Swift code nevertheless. And you can see it has the same kind of structure, right? I have a function called main, which is going to be my entry point. It's going to get a dictionary, and I'm going to look for two parameters, right? I'm going to look for a currency and an amount, right, to convert into Bitcoin. And then what we do is we call this function that I've created, which goes to talk to CoinDesk. So it sends a HTTP request to CoinDesk, which is a Bitcoin wallet, and they publish real-time prices of Bitcoin in different currencies. So it goes, makes HTTP request, passes the JSON that comes back, and then down the bottom does a bit of math to convert from euros, sterling, whatever, into the equivalent of Bitcoin using the data that came back from the API. So I've finished the code, right, 30 or 40 lines, and now I can deploy it. So I can say IBM Cloud, Whisk, action, create, so just call it Bitcoin, because it's Bitcoin API, conversion.swift. And then, once it's created, I can test it out. So I'm going to say action invoke my Bitcoin serverless function. And I need to pass in two parameters, right? I need to pass in a currency. Let's try US dollars, because why not? And an amount. And let's try 10,000, because Bitcoin is super expensive. And hopefully what should happen is it should evaluate my code, call CoinDesk, and then return to me that 10,000 US dollars is at the moment about 1.53 Bitcoins. And I can try this with different currencies, right? So I can say, let's try euros, since we're in Germany, about 1.7. And I can try pounds to keep it old school. It's going to be about 2, right? 10,000, nearly, so one Bitcoin is about £5,000 at the moment. So you can see how quick this was, right? I wrote the Swift code, add the little handler, pushed it up, and now I've got my little serverless function I can call to do my kind of real-time conversion. Now, once you've created some serverless functions in the cloud, the next thing to think about is, like, how do you integrate them into your application, right? You're not going to integrate them through the CLI tool, right? That's not how you're going to do it. And OpenWhisk has like 3 different ways to integrate, to kind of invoke your serverless functions programmatically. I'm going to talk about. The first is using what we call the platform API. So the OpenWhisk platform has a well-documented RESTful API with a Swagger doc and all that kind of great stuff to interact with the platform, to create serverless functions, to invoke them, to get the results of computation. And as any application, mobile app or otherwise, that you can send an authenticated HTTP post request from, you can invoke your serverless functions programmatically. And when I'm using the command line tool, when I type whisk action invoke, all that CLI does under the covers is just send HTTP requests. It's a very thin wrapper around the kind of platform API. And actually, there's client libraries for Swift and other languages to make the process invoking them programmatically much, much easier, so you don't need to manually be all constructing the HTTP requests. So you can use the platform API, and that works really, really well. But it requires you to use your developer credentials, your username and password, to talk to the platform API. And often when we're building things like APIs, we want them to be public. We want anyone to be able to call them without having to share my developer credentials to the world. So Whisk has 2 different ways to turn your serverless functions into just like public URL endpoints. And the first is by turning them into something we call web actions. So there's a special flag you can set when you're creating them on the command line, --web to true. And what that will do is the platform will then give you back a unique URL on the platform API that you can invoke with an unauthenticated HTTP post. So you'll still be talking to the platform API, but now you don't need any authentication to be able to call that serverless function. And we call these web actions, and web actions are great for testing, development, or if you just need something very quick and simple, like a webhook endpoint, where you just want a HTTP endpoint to call your function. Web actions work really, really well for this. But if you build big APIs, right, you're probably building APIs at work, you're probably thinking, well, hold on a minute, like, what about API routing, right? I want different serverless functions to process different kind of requests coming in, different paths in the URI. Like, what about rate limiting? I don't want people to call my serverless function too much, it costs me too much money, bankrupt me. What about authentication? I want users to be able to authenticate with their own credentials, and I can use those with third-party services. Like, how does that work if you're using web actions, just these little URL endpoints? And if you were going to use web actions and you wanted some of these features, you would kind of have to implement them yourself in the code. You'd have to look at the HTTP request parameters coming in and work out how to do this kind of stuff. And that's obviously not a very kind of scalable, sensible solution for a big enterprise API. So the solution here, and this is what we do in the serverless community, it's kind of like the pattern, is that if you're going to build big public API endpoints, you always use services in the cloud called API gateways. So all big cloud providers have these kind of API gateway services, and what API gateways allow you to do is define public API endpoints that then can proxy private APIs in the background, and you can create public endpoints for your serverless functions that talk to the platform API. And the great thing about API gateways is all of those features we talked about, like routing, like authentication, like rate limiting, they just become configuration in your API gateway you don't have to think about whatsoever in your code, which is another nice thing you don't really have to think about whatsoever. So let's do this now, right? Let me take my Bitcoin function and let's turn it into a web action, and then let's turn it finally into a fully managed API endpoint in about 2 or 3 minutes. So I'll go back to hiding my slides and mirror my screen. And we'll start off on the command line again, and I'll just turn it into a web action, right? Just show you the one command, and it will be a public endpoint that pretty much anyone in this room could talk to. So I say IBM Cloud Whisk action. Instead, it's already been created, so I need to update it. So I say update Bitcoin, set the flag --web to be true. And when it's done that, then I can retrieve details about the action. So I'm going to say get the details and give me the URL, give me the web action URL. So down the bottom, I have this endpoint here, which is on the platform API. Now, I have a little utility in my shell that allows me to make HTTP requests. So I'm going to do that using the utility. So I'm going to say send a GET request to the web action URL. I want back some JSON. And we're going to provide parameters just as query params, right? So I'm going to say amount, 10,000, and currency equals US dollars, equals US dollars. And what we should get back is basically the same responses we had before, but now through a kind of public URL endpoint, right? So you can see HTTP 200, yay, and again, 10,000 US dollars is about 1.53. So I think that's changed. Bitcoin has changed in about the past minute. But you can see now this is a public endpoint, right? Anyone in this room could start to use this, no problem. We're setting one configuration parameter, turns it into web action. Now I can talk to it, kind of easy peasy. But if you were going to use this in a real application, you would want that kind of API gateway endpoint. And one of the nice things about OpenWhisk is that it comes built in with an API gateway service. It's part of the open source project. And you can interact with it on the command line, so I can type like Whisk API, create, all this kind of stuff. But I think it's more intuitive if I show you through the web console. I just think it kind of makes a bit more sense. So I'm going to swap to my browser and hopefully go to the Cloud Functions Management page. So this is just like the management page for Cloud Functions, and you can see down the bottom, I have this little APIs tab. And so if I click it, what it's going to do is it's going to take me to the kind of API gateway section. Hopefully we can create a new API. So it's in the right region, it's in the right space, this should be good. Here we go, right? So it's going to say, okay, create an API, yep. Give it a name, let's call it Bitcoin. give it a path, right? So I can say /API. And now I can do the routing that I talked about. I can say when someone calls a subpath Bitcoin with a get, just like call my action Bitcoin and return me some JSON. Yep. And because I'm using an API gateway, right, it means that I can turn on all of these features. So authentication, rate limiting, auth, cause. These are just flags in the API gateway. I don't need to think about it in my code or write code to be able to do this stuff. It's completely managed for me by the API gateway service. So hopefully, if I click Save now, what it's going to do, it should give me a new endpoint, which is for the API gateway, that I can call, which will just call my serverless function and just return me the same response. So hopefully, there we go, right? If I had my own domain registered with the platform, it would be my own domain. But since I don't, it's just giving me a random domain on the API gateway. And it should work the same way. Now I go back to my command line, type HTTP GET. I put the path in, put the subpath in, put the parameters, amounts, let's do 10,000. Currency equals US dollars. And hopefully it should just work, right? It's going to give me back that 10,000 US dollars is about 1.538 Bitcoins, right? And so, but you see the difference this time. I'm not talking to the platform API, I'm talking to the API gateway, and that would probably be your own domain, right, if you're using the service. But this is now this is like a fully managed API gateway endpoint. I can do authentication, rate limiting. I could use this in a real application, no problem. And it's just going to work. So within 10 minutes, I've taken some Swift code from a laptop, I deployed it to the public cloud as a kind of scalable microservice, and I've turned it into a fully managed API endpoint, all without touching or thinking about any of that horrible infrastructure under the covers. There we go. So, how are we doing? Okay, half an hour. So, hopefully you can see why, I'm personally so excited about serverless, kind of technology I represent, why I think it's such an exciting and new and awesome way to kind of deploy software to the cloud. And maybe you agree with me now that servers kill your productivity and ready to go back to your office and start setting fire to all your infrastructure. But before you do this, right, I think it's only fair to also talk about some of the challenges of using serverless to build applications today, because serverless is still very new technology. It's only a couple of years old, and it definitely comes with some trade-offs and constraints and just things it doesn't really work for at the moment. So I'm going to talk about two specific challenges around using serverless to build apps. One is specific to Swift, server-side serverless Swift, and the other is generic. It doesn't really matter what language you use. So the first challenge is if you're going to use service, you need to understand, this is very important, the difference between what we call warm and cold activations and the effects this can have on the performance of your APIs or serverless functions. So what does this mean, like warm versus cold activations? Well, if you were really paying attention, you just weren't on Twitter when I was doing my demo, you might have noticed this kind of behavior, right? When I first create my serverless function, you'll see that it's always a little bit slower to invoke than subsequent invocations. And that wasn't like bad Wi-Fi or some issue in the cloud, right? That was an inherent behavior of how serverless platforms work. And to explain why this happens, right? When we first invoke a function, or if it hasn't been invoked for a long time, we call it cold. Subsequent invocations we call warm. Why is the difference? Why should this happen, right? I'll quickly drop beneath the covers on serverless platforms and explain how they work to explain why this kind of performance characteristic comes in. So when you type whisk action invoke, right, your CLI goes and talks to the platform API, sends a HTTP request, and then waits for the response. A number of things have to happen, like under the covers in the serverless platform, for you to be able to get the result of your function being executed. And at a high level, these are the kind of steps that the platform goes through. So most serverless platforms under the covers, at least the ones we kind of open source we know about, use basically Docker under the covers. They kind of have a pool of containers. They find a spare container. They start it. They inject your code, your Swift code, into that environment, into the file system. Because Swift is a compiled language, it quickly runs the Swift build to turn it into a binary. Then it executes the binary, calls the function called main, passing in the event parameters, and whatever you return is then serialized back out as your kind of API response. And that's what we call cold invocation, right? All these steps have to happen. But to improve performance in serverless platforms for subsequent invocations that happen within like 5 or 10 minutes, what the platforms do is, rather than just saying, okay, if we get another invocation straight away, we're not going to go through all of those steps again. We're going to reuse one of the old containers, right? And when we reuse an old container for your function, what that means is that we don't have to inject your code into the environment. We don't have to start the container because it's already there. It's just been paused. We don't have to inject your code into the environment because the code is already there. And actually, we don't have to run Swift build, right? We can just recall the old executable with the new event parameters and serialize you back out. And that is why kind of subsequent invocations are always a little bit quicker because it's not having to run the Swift build, right? Swift build is not known for being particularly fast, and this is normally the source of the delay during what we call cold activations. So the question you have to ask yourself if you're going to be using this stuff is does this matter to you, right? If you're building some kind of webhook endpoint, you don't really care whether you get it takes 1 second or 3 seconds to process your request, right? It's not really user-facing. But if you're building big, very latency-sensitive APIs, it's probably something you're going to care about. And if it is, I'm going to give you a trick to kind of mitigate some of the performance impacts of cold activations. And the trick is this. Rather than pushing your Swift code into the platform and having the platform compile it, you can actually run Swift build locally to generate the binary and deploy the binary directly. And when you do that, during the cold activations, the platform starts to start a container, it starts to inject your code, but it will detect that you've deployed a binary rather than source code, and it will just skip out Swift build and call it as if it's been a warm activation. And that really narrows the difference between what we call warm and cold activation or cold start time. And so if you were going to be doing real production stuff with this kind of stuff, I would generally always recommend deploying the binary in production, running the build locally and deploying the binary rather than deploying the code if latency is something that's very, very important to you. So this issue is very Swift specific, right? It's specific to some other languages, but any language that gets compiled, it's something you need to kind of think about. JavaScript and Python, because they're evaluated, they don't really have such a big problem. The next challenge we're going to talk about, a final challenge, is this is generic for just serverless applications in general, right? And it's around compute limits. This is things that developers often run into, I find, when they start to use serverless. Serverless cloud platforms are very opinionated about the kinds of applications they expect to run. And they're designed for modern, cloud-native, 12-factor app microservices that scale horizontally and all those kind of buzzwords. Serverless platforms aren't for lifting and shifting legacy apps and running them in the cloud, right? It's not designed for that. And one of the ways that the platforms enforce this architectural styling of modern cloud-native microservices is by limiting access to some computational resources on the platform. So, for example, this is a list of some of the things, some of the kind of limits on OpenWhisk, and these are very typical of any serverless provider. They all have the same kind of limits. The big two that people run into, I think, when they get started, the first is timeouts. When your serverless function gets called, on OpenWhisk you have a maximum of 10 minutes to finish processing that request and return. If you haven't, the platform just kills off your process and returns an error. It's the same on all platforms. They give you between 5 and 10 minutes. So if you have some batch job or some process or some algorithm that takes like an hour to compute, right, it's not going to be appropriate for serverless unless you can kind of parallelize the workload somehow and run it in parallel. The other one is memory. Serverless functions, you get charged for the duration they're running, but also the amount of memory they allocate, and you can change the amount of memory to give better performance, but also constrain costs to take memory away. But the amount of memory a serverless function can have normally is like half a gigabyte, quarter of a gigabyte, maybe 2 gigabytes on some platforms. It's not terabytes of RAM. So if you have, again, some process that is very memory intensive, needs terabyte of RAM, half a terabyte of RAM, you're not going to be able to run it on a serverless platform at the moment, right? All the platforms limit you to sort of half a gig, 1 gig, 2 gig, that kind of range. So it's very important if you're going to be using serverless to really understand the limits of the platforms, why they're there, and build your architecture to kind of work with this, right? Don't try and fight it because you won't win. But they're there for a good reason. They're there to build your architecture that kind of supports running in the kind of public cloud infrastructure. So I said at the start of this presentation that servers kill your productivity. And hopefully maybe now you agree with me, right? All that time we'd have to spend patching kernels and managing VMs and thinking about Kubernetes and middleware and all that kind of stuff, right? It's kind of, I think, time wasted. It's not time spent on your product, listening to users, pushing out updates, fixing bugs, or it's time just kind of managing providers, kind of VMs and things like that. And I think as developers, if you're new to backend development, it can feel after a while that you get held hostage by your infrastructure, right? You're going to want to spend time in Xcode. You're not going to get to do that anymore. You're going to be logged into your cloud provider's console. So I want to kind of encourage people, right? If you're getting new to backend development, especially doing Swift, think about embracing the serverless revolution, right? Burn your servers, deprovision your VMs, delete your containers, be free forever from the tyranny of looking after infrastructure. But most importantly, upgrade your productivity, right? Get back to writing Swift and Xcode and not on kind of debugging VM issues in your cloud provider's console. So thank you very much for listening. If you want any of the resources from this talk, if you go to the bit.ly link at the top, Burn Your Servers, then you'll get to a GitHub repo with all the demos and examples and code. You just follow along at home. If you like this and you want to start doing it and you're going to need help, right, there's two places. Slack, we have a very big Slack community. Come and ask in there. Or if you go onto OpenWhisk on Stack Overflow, I will probably answer because I do most of the Swift stuff. Or if you need a more personal introduction, just at me or at OpenWhisk, and we can come and help you out. So yes, thank you very much.